Okay, lesson 1.8, day 1 is on composite functions. And these functions, as you probably remember, can be added, subtracted, multiplied, or divided. So if we have f of x plus g of x, this is just f plus g of x. F of x minus g of x, f minus g of x, multiplied would be f times g of x, and divided, it's just going to be f divided by g of x. But in this case, you have to specify that g of x is not equal to 0, because if it was, you would get in a lot of trouble. Okay, in the first example, let's say f of x is x squared, g of x, 1 minus x. So we're going to add these, f of x plus g of x. So that's going to be x squared plus 1 minus x, and then put it into a more familiar form. So it's going to be x squared minus x plus 1. Okay, so let's subtract them. F of x minus g of x. So we have x squared minus, and whenever you're doing subtraction, you want to make sure you distribute your negative sign, and the best way to remember to do that is put things in parentheses. So that gives you x squared plus x minus 1. Okay, multiplying, we have x squared times 1 minus x. So that's going to be x squared minus x cubed, or if you prefer, it would be a minus x cubed plus x squared. And then dividing, so we're going to f of x, which is x squared, divided by g of x, which is 1 minus x. And then we have to specify the domain. X is not equal to 1. Okay, let's look at composite functions. And we're going to look at f of g of x. So this is pronounced f of g of x. That's how you say it. And in the book, you'll also see it like f with a little o, g of x in parentheses. So this means the same thing as f of g of x. Sometimes I write it this way, sometimes I just write it this way. So you'll see it both ways in the book. So let's do an example. Let's use our f of x that we used before. F of x was x squared, and we used g of x was 1 minus x. So if we want to find f of g of x, that means we take whatever g of x is, which in this case is 1 minus x, and we substitute that in for the x in x squared, but we still have to keep the squared term. So this is going to be f of 1 minus x. And so this is going to be equal to the 1 minus x, which is replacing this x here. And this is squared, so we have to square this term. So then if we wanted to FOIL it out, it's so 1 minus x squared is going to give us x squared minus 2x plus 1. So that is f of g of x. Okay, here's an example. We have f of x is equal to x over x plus 1. G of x is equal to x cubed, and we want to find f plus g of x. So that's going to be equal to x divided by x plus 1 plus x cubed. Well, we know we can't leave it like that because that's not the simplest form. We have to put it over one fraction. So we're going to multiply top and bottom by x plus 1 plus 1. So then our numerator is then x plus, I would distribute x cubed times x is x to the fourth. X cubed times 1 is x cubed. Common denominator, x plus 1. And we could clean this up by having descending exponents. So it'd be x to the fourth plus x cubed plus x over x plus 1. Okay, let's do the next one, f minus g of x. Okay, so we have our x over x plus 1 minus x cubed. Same thing, we're going to have to multiply top and bottom by the denominator, x plus 1 over x plus 1. So that's going to be our numerator is going to be, well, we have a minus x cubed times x, so that's going to be negative x to the fourth. And we have a minus x cubed times 1, so that's a minus x cubed. And then we have our plus x all over x plus 1. All right, so now let's do f times g of x. All right, so we have x over x plus 1 times x cubed. Well, this is an easy one. X to the fourth over x plus 1. All right, so our last one, f divided by g of x. So we have our x over x plus 1 divided by g of x, which is x cubed. So we're dividing fractions, invert and multiply. So this is x over x plus 1 times x cubed. Oh, we have to invert and multiply. Times 1 over x cubed. So that's equal to x divided by, we'll just go ahead and multiply this out, x to the fourth minus x cubed. Well, we can simplify that. Factor an x out of top and bottom, we have 1 over x cubed minus x squared. And we can simplify that a little bit, factoring out x squared out of the denominator. 1 over x squared times x minus 1. Okay, so that's add, subtract, multiply, and divide. So let's go ahead and do a few other things. These are kind of fun. So let's do f of g of x. Okay, so we take, this is going to be f of g of x is x cubed. So we're going to substitute the x cubed in for the x in f of x. So that gives us x cubed over x cubed plus 1. All right. What about, let's do g of f of x. G of f of x. So we take our f of x, which is the x over x plus 1, and we do whatever we do to the x in g of x, and that is cubing it, so we cube the whole thing. Now here we have to specify a domain. X is not equal to 1. We didn't specify the domain. Let me go back. I'll do it in red. We didn't specify the domain of f divided by g. So the domain of this is x is not equal to 0 or x is not equal to 1. Okay. Got to remember to do that whenever you're dividing, when you have a g of x or something in the denominator. Okay, so what about, let's do g of f of 2. So it's the same as this, except we're replacing 2 instead of x. So then we have 2 divided by 2 plus 1, and that's all cubed. So that's going to be 8 over 8 plus 1. It's going to be, no, 2 plus 1 is 3, 3 cubed, 27. Okay, so that's what it's going to be, 8 over 27. Well, let's go ahead and do f of g of, let's pick a negative 2. Okay, our f of g was here. So we want to substitute in our negative 2 for the x. So it's going to be negative 2 cubed over negative 2 cubed plus 1. Negative 2 cubed is negative 8. Negative 2 cubed, again, negative 8. Plus 1 is a negative 7. So that turns out to be 8/7. Now, one last thing. I noticed on the last quiz, some of you were using decimals where it's more appropriate to use fractions. For example, there's no reason why I would change this fraction 8/7 into decimal. It's perfectly fine as 8/7. So whenever you can, leave an answer in fractions instead of decimals. Okay, that's it for day 1, and I'll work on day 2 next.